Okay, so I'm going to read it. Here we go. On the first day of winter, an entire field of trees starts losing its flowers. The number of locusts remaining alive in this population decreases rapidly due to the lack of flowers for them to eat. The relationship between the elapsed time t and days since the beginning of the winter and the total number of locusts n is modeled by the following function. So we got t, which is days, and n, which is number of locusts. So this is a number of locusts is dependent upon the number of days. And look, the number of days is divided by 2 before it applies to this rate that we're multiplying to 8,950. Complete the following sentence about the daily rate of change in the locust population. Every day the locust population is multiplied by a factor of what? Now, this is the factor, right? This is the factor, 0.49, but it's being raised to the 1/2. So, well, what is the factor actually on day 1? And what is the factor actually on day 2? Make a table of like 3 values first and see if you guys can do it yourself before I do it. This is a manipulating type of a problem, okay? So I gave you guys a little time to think about it, and you guys honestly all look completely lost. So here we go. Here's my table. T is in what? Is in days. Days. And then you have n, which is the number of what? The number of locusts. And so we don't need to see 0, because 0 is obvious. If I plug 0 into this, then this would be 0.49 raised to the 0 power. And what's anything raised to the 0 power? 1. And so it's 8,950 times 1, and that doesn't change anything. So it's not going to tell us anything. So let's look at day 1. Day 1, what happens? We take 8,950 and we multiply it by 0.49 raised to the 1/2 power. Okay, now I'm just going to do one simplification on this one because this is actually really simple. I mean, you guys might not think so, but it is. It's 0.49 raised to the 1/2 power, which is the same as the square root of 0.49, which you guys know to be what?
0.7.
Yeah, because you guys know this. You guys know the square root of 49, right? Well, the square root of 49 is 7. But we need it to be 0.49, so it's 0.7, right? 0.7 times 0.7 is, see, when you do this, when you learn how to do the decimals and stuff, you go 7 times 7, which is 49, and then we have 1, 2 decimal places we have to move over, 1, 2, and so we put our decimal right there. So it works, right? It's 0.7. And so up here, I'm going to write 8950 times 0.7. Okay, now let's do the next one, because we're trying to see the pattern here. What is the factor that's being multiplied, the new factor that's being multiplied every day? We have 8950, 049, and this time it's to the 1 power. Oh shoot, this one is just 0.49. Oh, that's weird. I don't see, well, right away, maybe you guys don't see the difference here. Like, what did it increase by? Okay, now let's look at day 3. Day 3, we plug in the 3, what do we get? We get 3 over 2. Now, how do you guys say this, 3 over 2, like officially? Do you guys know how? I guess. 3 halves, right? It's 3 halves. So that means there's 3 of these. It goes 8950, 0.49, 1/2, 0.49, 1/2. How many of these? 3 halves. I don't know if this helps, but this makes a lot of sense to me. I hope it makes sense to you. Do you guys know what this is? We went over it right here. What is 0.49 raised to the 1/2 power?
0.7.
It's 0.7. So this is 0.7. This is 0.7. And this is 0.7. Now I think you guys might see it. You guys see it yet?
Yep.
Maybe? Maybe not? Did you see that this actually can be 0.7 times 0.7?
Yep.
Right? Because there's 2 halves in this one. There's 2 halves in the 1. So look what's happening. You see the difference for each of them? What are we increasing by every time?
0.7.
We're increasing by a factor of 0.7 every time, and that's your answer.
Oh, I knew.
Every day, we're increasing by a factor of 0.7. That's your answer.